All right, so let's look at a single replacement reaction example now, okay? Okay, so I'm going to start with aluminum sulfate, and then we're going to react it with calcium, solid calcium metal, and the product we should get here will be calcium sulfate, and aluminum metal. Alright, so what you have here is a two-part ionic or acidic compound. A two-part ionic or acidic compound and a metal that's by itself. Now it can be a metal or it can be a halogen, but it doesn't really matter. But you have to have a one-part species and a two-part species that's either ionic or acidic. Ionic or acidic. Okay? And for it to be a single replacement reaction, what's going to happen is this one part over here is going to come over and kick out the part of the two-part compound that it's like. Somebody want to open that door over there for me? Okay. And in fact, if you look over here on this side, aluminum left the sulfate and the calcium took its place with the sulfate. Who's that? Brandon? I don't know why, but sure. Come on, Brandon, smile. That's all right. Okay. He's famous. All right. Okay? So you have a single replacement reaction when an elemental form replaces something in a two-part formula that it's like. Okay? Now there are two kinds of replacements that can happen. Okay? You can have halogens that it's like. And when I say that it's like, this is what I'm talking about here. You can have halogens replace halogens. That's one of those two things. And the second one is when a metal replaces a metal or hydrogen. So metals can replace metals or hydrogen. Halogens can replace halogens. Okay? Alright, so let's go back to our equation now. We're ready to balance the equation. We've got everything else there we're ready to balance. I hope you're writing this down with me, practicing. It's really going to be more helpful for you than just watching. I have aluminum, I've got sulfur, oxygen, and I've got calcium. Okay? So we can make our little spreadsheet of sorts here. Okay? And now I start counting all the elements or atoms we have. We have 2 aluminums. This sulfur is in a parentheses. Now in the sulfur species, there's no coefficient after the sulfur, which means there's just one of those, but the 3 outside the parentheses means it's 3 times everything inside. So I must have 3 sulfurs then. And how many oxygens? 12. And there's only 1 calcium. Okay, over here, just got 1 aluminum over here. Got 1 sulfur, 4 oxygens, and 1 calcium. So now we want to go through and balance everything. We always save oxygen for last. Okay, so we're not going to do it first. We're going to start with one of these others. And I can start with aluminum. That's at the top. Doesn't really matter. I can start with sulfur, but I'm going to start with aluminum. I have 2 aluminums here. To get 2 aluminums on this side, I can't mess with any of the subscripts in the formulas. I can only put coefficients outside to balance the equation. Once the formulas are balanced, you must leave them alone. So that's going to give me 2 aluminums. Now I want to try to fix the sulfurs. I've got 3 over here on this side and only 1 on this side. To get 3 sulfurs, I need a coefficient in front of the species that contains sulfur. Can't put coefficients in there. Once the formulas are done, you have to leave them alone. Only coefficients will allow you to balance an equation. So I'll put a 3 outside. That's going to give me 3 sulfurs, but it also changes the number of calciums to 3. And now the oxygens get changed. I got 4 oxygens here, and everything's being multiplied by 3. So how many oxygens do I have? 12 oxygens. Okay? Well, we're almost done. The only thing left is the calcium. And I've got 3. Yes, I put a 3 out in front of the calcium here, and that's going to take care of everything. Okay? So now we have a single replacement reaction. And it can be single displacement or single replacement. I like displacement personally because I like to think of calcium displacing aluminum, kicking it out. Okay? So when CJ is trying to get into the backfield and tackle a runner, he's got to displace the lineman first. Right? Huh? That makes sense? Okay? And when Brandon is trying to intercept the pass, he's got to displace the receiver to get to that ball. Right? Okay? And let's see, Darrell, where you play? Defensive end. All right, same thing with CJ there, okay? Whenever you're trying to get to that quarterback or the running back, you got to displace a blocker. And usually ends get blocked by a running back or something, right? A pulling guard, okay? You got to get them out of the way. All right, so you got to displace them, okay? All right. So it's single replacement reaction. Okay? It's not single. It's really not even a single replacement. It's a single replacement reaction. Okay? All right, so that's a single replacement reaction. So we've gone through examples of combustion up here, double replacement, and now single replacement. So now we need to look at examples of synthesis and decomposition. Synthesis and decomposition. Okay?
Synthesis is just the only word like in the name. Like you just say synthesis.
It's a synthesis reaction still. Okay? Okay? So, what would this look like? What do you think this is? Not synthesis. Synthesis is when you take 2 or more compounds and kind of put them together to make a larger compound. This is decomposition. Yeah, Dev was right. It was a decomposition reaction. Okay? So what we have, the way you recognize that is this is a larger compound here on the left. Okay? And it's becoming a couple of smaller compounds. So it might be 2 or 3, but it's becoming smaller compounds. Okay? So the larger compound can become any number on the other side more than that one. Okay? So because we have a larger compound becoming smaller compounds, this is a decomposition reaction. Okay? So we need to balance it. And it's already balanced. But now, it's out from Missouri, you proved it, we're set. Okay? So what's happening here? This is synthesis. We got two or more compounds combining to make a larger compound. Okay, so this is a synthesis reaction. And you need to balance this reaction using an atom inventory. Okay? So balance the reaction, please. Balance the reaction, please. Balance the reaction, please. Balance it. Balance it. I've already written down there, so I've already classified it for you. Okay, I wrote down that it's synthesis, a synthesis reaction, so I classified it for you. Now you're going to you're going to balance it, okay? Okay, write these three equations down. Everybody write these three equations down.